So, on Wednesday, listen up. On Wednesday, when we do the Unit 6 review, guys, please stop talking over me. On Wednesday, when we do the Unit 6 review, I will be checking your Unit 6 notes, which should be an easy 10 points. So if you have been absent any day, you need to get on Google Classroom and get the notes, and I can get you paper copies or you can print them out from there. Okay, so what we're looking at is a system of inequalities. We did linear inequalities on Friday. Now we have a system. A system just means what? More than one, usually two. For this class it will be two. You could have 3 or 4. This class will be 2. So we are looking at 2 inequalities. That's all we are doing. A solution to a system of inequalities is the overlapping region. So all you're doing is you are doing what we did Friday and what we did on the warm-ups, but you are doing it twice, and you are looking at where the shadings overlap. That's all we're doing. So we'll do about 4 examples, and then you'll have time to get the homework done today. Okay? So my solution is where the shadings overlap. So you're going to graph one of the inequalities, you're going to graph the other inequality, and then you are going to see where the shadings overlap. So let's look at number 4. If I look at 4, I have x is less than negative 4. How do I graph the inequality x is less than negative 4? Negative 4, 1, 2, 3, 4 on the x-axis. So put a point on the x-axis at negative 4. If it's x and a number, it's always what type of line? Vertical. Dash or full? Dash. Okay, so we graphed one like this on Friday. So x is less than negative 4. Put a point at negative 4 on the x-axis. It's a vertical line. Which way do I shade? X is less than, so it's to the left. Now don't shade it super dark. So when you're shading your first inequality, don't shade it super dark, because you are going to be putting another inequality on the same graph.
Whoops.
So get the first one graphed. X is less than negative 4. Get it shaded. So finish the first one, and then move on to the second one. 3x plus 2y is less than or equal to negative 2. Now what form is this in? Standard. So I need to solve this equation for y. What do I do to solve this for y?
Subtract 3x.
Minus 3x, just like we did Friday. So nothing is different except we're just doing it twice. So we're going to subtract 3x. So 2y. Guys, cut it out. We're not doing a lot of notes. So 2y is less than or equal to negative 2 minus 3x. So we are solving it for y like we have done numerous times. Divide by 2. You do not flip the direction of the inequality because I'm dividing by a positive 2. So remember, you only switch the direction if I'm dividing by a negative 2, or negative number. So y is less than or equal to, when I divide by 2, what do I get? Negative 1. Michael, take your headphones off, even though I'm sure they're not on. But okay, what's my slope? Negative 3 over 2x. Negative 3 halves x. Okay, so there's your equation in slope-intercept form. So let's graph this. What do I do first to graph this inequality? So put a point on the y-axis at negative 1.
3 over 2.
Yep. You can go up 3, but then you have to go which direction to? Left, because you have to get the negative. So if you go up, that's positive, so you have to go left. Or I can go down 3, right 2. Either way you want to do it. Okay. Now, when I graph this is an inequality, dashed or full line. Full. So it's a full line. Now you don't have to use a ruler because we don't necessarily care where the lines cross. We care where the shadings overlap. So this is where it's different than an inequality or an equation. Instead of having one point as my answer, we need to look at where the shadings overlap. That should be a key on the bottom. Now, Let's shade real quick. Y is less than or equal to. So if Y is less than or equal to, which way do I shade?
The bottom.
Bottom. Okay, so as I look at this, I ignore the first graph, and we just look at the graph, the line I just graphed. So Y is less than or equal to us, so I shade below it. So you ignore the first one, so you're just going to shade it separately. So I have that one. I am shading to the left because Y is less than. Just a second. So do the first inequality. Do the second inequality. My solution is where the shadings overlap. So what area do my shadings overlap?
What do you mean?
What area do the two shadings overlap? So the shading from the first inequality and the shading from the second one, where do those shadings overlap? No, I'm not looking for a specific point. What area? No, what? Just describe to me what region. What does the region look like where the shadings overlap? Okay, this, you're like, oh, figure. This little, almost shading darker where the two shadings overlap. Okay, so we do not have this triangle down here because that's only with the second one. We don't have this little triangle up here because that's only with the first one. So we are looking for the region where both shadings overlap, and that is the solution to both inequalities. So any point in this double shaded area is the solution to both of them. So we are looking for the solution to both of them. Now we're not looking for a specific point. This is where it's different than an equation. When we graph two equations, we are looking at the point where they cross. Now, since we're doing inequalities, I have lots of different answers. Lots of points are solutions. So we're looking for the area where the shadings overlap.
What do you mean by the area?
This, right here. This is the area. This area. Yes, you shade darker the area where they both overlap. That's it. Okay? Any questions on that? Yes?
So, the mouth is facing this way, you shade that. Mouth is facing this way, you shade that.
Yes, but it has to be Y. So if Y is less than, you shade below. You have to look at Y. If Y is less than, you shade below. If Y is greater than, you shade above. Yes? Okay, any other questions? Okay, a couple more. Let's look at 5 real quick. Yes? No, I said 3 or 4, and I'm going to do 6 if we're going to keep complaining. We're not doing a lot of notes. So the 15 minutes we do notes, I need you guys to actually pay attention. Colton, stay with us, please. Okay. So let's go ahead and graph this. We have my first inequality. We're looking at 5. 4x minus 5y is greater than or equal to negative 35. So you're going to graph each one. They're both in standard form, so for each one you're going to have to solve for y, which is nothing new. We've done it a lot. What do I do first? Minus 4x. Minus 4x. So negative 5y is greater than or equal to negative 35 minus 4x. Okay, so this is our review. Yep, we need to get y alone, so divide by negative 5. If I divide by negative 5, whenever I divide an inequality by a negative, I have to switch the direction. So this becomes y is less than or equal to negative 35 divided by 5, negative 5, 7. Negative 4 divided by negative 5, positive 4/5 x. Good. So you do each one separately. This is the first inequality, so we're going to solve for y, graph it, get it done, and then we'll move on to the second one. How do I graph this one? Yep. 1, 2, 3, 4, 5, 6, 7. The y-intercept is 7. Like your slope is what? 4 over 5. I cannot go up 4, so I have to go 1, 2, 3, 4. Which direction 5? Left, because it has to say positive. So if I go down, that's a negative. So I have to go left 1, 2, 3, 4, 5. So if you can't go up 4, right 5, you can go down 4, left 5. Dashed or full? Full, because it's less than or equal to, so it's a full line. Your lines don't have to be perfectly straight because we're not looking at the point where they cross. Michael, close your computer. We're looking at the area, the region where they cross. Okay, let's shade above or below. Y is less than. You always look at Y. Y is less than or equal to, so you shade below. Do not shade too dark because we're going to be graphing another one.
Boy, I'm so confused. What?
You have to look at the inequality where Y is by itself. Y is less than, so you shade below it. Huh? No, you don't do left or right. If it's less than, you always shade below.
Alright, so if it's less,
You shade below.
and greater.
Now, the left and right is confusing. I screwed up on that one. So if it's less than, you shade below it. Yeah. Okay. Any other questions on that one? So get the first one graphed by itself, get it done, get it shaded, and then move on to the second one. So finish the first one, then move on to the second one. The second one, x plus y is greater than negative 2. Yep. Good. Subtract the x. And we get y is greater than negative 2 minus x. Okay. So the second one, we only had to get y alone. So y is greater than negative 2 minus x. To graph this one, we are graphing it right over top of the other one. How do I graph this one? I go down 2. Negative 2 is the y-intercept, so I go down 2. Yeah, my slope is a negative 1, so I go down 1. Which direction 1? No, I have to get a negative. So down is my, down is my negative, right is my positive, so down 1, right 1. Dashed or full. Dashed, y is greater than, it's not equal to, so it is a dashed line. Okay. Now, y is greater than, so I shade above. Now, you ignore the first one, so you shade the second one like normal. It's above it, so you shade above the second one. My solution to both of these is what the region where the shadings overlap. Because the shading of one is the solution to one, the shading for the other is the solution for the other. So if I want the solution for both, I see where both shadings overlap. What area, what region do the shadings overlap? Can you just describe to me what region, where, what does it look like? The right triangle, this triangle over here. So shade that darker. So the area where they overlap, the shadings overlap, is the solution to both of them. So if I ask, is 0, 0 a solution to this system? Is 0, 0, is the point 0, 0 a solution to the system?
Yes.
Yes, because it is in the double shaded area. Okay. Is the point negative 4, 0 a solution to the system? So look at your point negative 4, 0. Left 4. Is that a solution to the system? No, because it's not in the double shaded. So in order for it to be a solution to both inequalities, it has to be in the double shaded area. Okay. Any questions on that? Okay, let's look at 9. Okay, let's try and graph this. 3x, top one, 3x minus y is less than 6. So you graph each inequality separately, completely separate, and then we look at where the area, the shadings overlap. 3x minus y is less than 6. Minus 3x, good. Same process as we have done tons of times. So you should be able to get through and look at it and see. We subtract 3x. We have negative y is less than 6 minus 3x. Do not forget, there's still the negative in front of the y. What do I do next? Divide by negative 1. Good. My inequality will look like is greater than. Good. You divided by the negative 1, so it switches the direction. Y is greater than. And then start dividing.
Wow.
6 divided by negative 1, negative 6. Negative 3x divided by negative 1, positive 3x. Good. So again, exactly like Friday, same exact process, except you are doing it twice. Michael, keep your head up, please. Okay, let's graph this inequality. Get the first one completely done, and then we'll move on to the second one. How do I graph this?
Go
Down 6, put a point. What's the y-intercept? Yep, my slope is 3, or 3 over 1 is positive. So up 3, right 1. It's an inequality. Dash or full? Dash. It's just greater than. It's not equal to. So it is a dashed line. Your lines don't have to be perfectly straight. Y is greater than negative 6 plus 3x. So I shade. Y is greater than. So I shade.
If you don't put the dash
don't-
line, if you put a full
I would
line,
not give you full credit. That's
I
part of
think
the.
you won't count off the whole problem.
No, but I always give partial credit, but yes. Okay, y is greater than, so above or below? Above. You only do left and right when you have like a vertical line. That was my bad Friday. So y is greater than, so I shade above it. Okay, any questions on that one?
Second line.
Okay. Second line, 3x minus y is greater than negative 2. Minus 3x, subtract 3x first, good. Minus 3x, we're not going to do 11, you can run into that space, I don't care. Minus 3x, so I have, I'll do it right underneath it. Negative y is greater than negative 2 minus 3x. Divide by negative 1, good, we're getting the hang of this stuff. Divide by negative 1.
Y is less than.
Yep.
2 plus.
Y is less than, you switch the direction because you're dividing by a negative. Y is less than positive 2 plus 3x. Now, what do you notice about the two inequalities?
They're the same.
What's the same? If I look, yes, my slope for both inequalities are what? 3. My slope is 3, so what do I know about the lines?
They're parallel.
They're parallel. So is my answer no solution right off the bat? No, because I'm not looking where the lines cross when I'm doing inequalities. I'm looking for where the shadings overlap. So let's graph the second one. The y-intercept is 2. So go up to the y-axis. The y-intercept of 2. My slope is 3 over 1. So we are going to go up 3, right 1. Even though they are parallel, it is not no solution. That sounds bad grammar. It is not no solution because we are not looking where the lines overlap. We are looking where the shadings overlap because these are inequalities. Dashed or full line. Dash is just y is less than, so it's a dashed line. Again, your graphs may look kind of weird. They don't have to be perfect. So I have the other one graphed. Now let's do shading. Y is less than, so I shade. Y is less than, so I shade below. So we're going to look at my inequality, which is this green one right here, and I ignore the first one, and I shade below that one. Now this graph looks messy, that's why I did this one with you. So we have this inequality shaded to the above it, the other one shaded below it, my answer to a system is the area where the shadings overlap. What region do the shadings overlap? Right in the middle, this little rectangle in the middle. So you're going to shade darker that little area in the middle.
That's messy.
It is. So, what ordered pair, give me an example. What is an ordered pair that is a solution to this system? 0, 0, because it's in the double shading. 1, 1 is in the double shading. So any point in the double shaded area is a solution to this system. Doable? Okay, kind of messier than Friday, but the exact same idea. Okay? So let me go and pass out the homework. That's it for notes. I want to make sure you have plenty of time to get this done.